Hello everyone. Today I am going to teach chemical kinetics. So listen carefully. See, chemical kinetics. See, from the name itself you can understand kinetics. No doubt we are dealing with the speed of the reaction or velocity of the reaction, or better to say, how much time the reaction may require to complete. So, all these aspects were studied under this chemical kinetics. Okay, so listen, all of you carefully. See, it is the branch of chemistry which deals with this chemical kinetics part deals with it, which deals with first and important thing is a rate of reaction, and the second one factors influencing rate of reaction, third one half life period of a reaction, next, in what time, how much extent is completed? After 5 minutes, what extent is completed after? So, extent of reaction with respect to time also we can understand. Okay? How much extent reaction has completed in certain time period. And finally mechanism of the reaction, right? You can predict mechanism of reaction, but there is a small important point here. You cannot get 100% certainty. See, kinetics will give approximate mechanism of the process. Okay, so mechanism of the reaction you can predict, but 100% it is not certain. See, 100% certainty to nahi rahega. Approximate mechanism you will get it. So, in chemical kinetics, we use it to describe all these aspects. What we describe? Rate of reaction, factors influencing rate of reaction, and after that half-life period of the reaction. Again, how much extent of reaction is completed in certain time period, and mechanism of reaction, but it is 100% not sure. Okay, so let me go through one by one. Right, first I am going through rate of reaction. Okay, how you can describe rate of reaction? I'll have you listen carefully. Okay, जनरली केमिस्ट्री में रिएक्शन मतलब क्या होता है? So usually what we call reactant is completely converted into product. This is the process. So the process of conversion of reactant into product is considered to be reaction. So initially reactant is maximum, product is always zero. Babu, at the initial step, starting stage of the reaction, reactant ज़्यादा होता है, product is zero. Next, after completion, see, after completion of reaction, अरे reaction complete हो गया. After completion of reaction, reactant zero हो गया and product maximum हो गया. तो during the course of reaction, what happened? Reactant concentration decrease हो रहा है, right? Reactant concentration धीरे धीरे कम हो रहा है, decrease हो रहा है. Product का concentration धीरे धीरे क्या हो रहा है? Increase हो रहा है. This is happens during course of the reaction. So here rate means what? Change in concentration with respect to time. The change in concentration with respect to time is considered to be rate of reaction. So with respect to reactant you can express the rate, or with respect to product also you can express the rate. So this is a change in concentration with respect to time is considered to be rate of reaction, or simply velocity of reaction. Okay, understand? So how you define this rate? So what's your definition now? You can write with respect to reactant, with respect to product. Okay, why we have to go through lengthy? Just to go in a shortest way. So that rate of reaction means the change in concentration, of reactant or product per unit time during the course of reaction. During the course of the reaction is called as a rate of reaction. Understand all of you? The change in concentration of reactant or product per unit time during the course of reaction is considered to be the rate of reaction. So therefore rate is equal to, or rate of reaction is equal to, कैसे लिख सकते हैं आप? Change in concentration divided by time. Okay, so rate of reaction is equal to change in concentration divided by time. Okay, now what are the units with respect to this formula? Units क्या होता है? Right, change in concentration always expressed in mole per liter into time inverse. Or if you want to time basic time units में लेना चाह रहे तो mole, liter inverse and second inverse. Mole, liter inverse and second inverse. Okay. So rate of reaction can be defined like this: change in concentration by time, and these are the units of rate of reaction. And one more important point: for gaseous phase reactions, all of you listen carefully. For gaseous phase reactions, a rate can be written like this: change in partial pressure. For gaseous phase reactions, a rate can be defined as a change in partial pressure to the time. मतलब ratio of change in partial pressure to the time is considered to be a rate in case of gaseous reactions. Therefore, units if you consider, यहाँ पे क्या लेते हैं? Atmosphere into time inverse or atmospheres into second inverse. अगर प्रेशर एटमॉस्फेयर्स में लेने से ठीक है, नहीं है तो mmHg into time inverse, centimeters of Hg mercury column into time inverse. Like that you can take the units of rate of reaction. So this is a rate of reaction. Now listen all of you. In general, rate of reaction is expressed in two terms. Okay. See, all of you listen carefully. Rate of reaction is expressed in two terms. Okay, let me go through in detail. Rate of reaction is in general expressed in two terms. What are those two terms? इसमें first average rate. The first and important thing is average rate. Okay, rate of reaction is expressed in two terms, in which the first one is average rate. See, what is average rate? Listen carefully. The ratio of total change in concentration. The ratio of total change in concentration to the total time period Right. See, the ratio of total change in concentration to the total time period is called as average rate. It is called as average rate. It is not significant in our chemistry. Q. It is not significant Q because it covers a large time interval. So ज़्यादा टाइम लेते हैं ना, एवरेज रेट मतलब यहाँ पे क्या दिया हो, the ratio of total change in concentration to the total time period. That's why it covers large time interval. So it is not significant in our kinetics. Calculation के लिए ये तो significant नहीं है, ठीक? So it is not significant. So average rate can be written like this. Average rate can be written just to go through delta, मतलब concentration by delta t. Changing concentration by changing time period, and that rate covers large time interval. Okay, so this is about average rate. इसको हम graphically explain कर सकते हैं. Average rate को we can make a graph also. मतलब if you consider concentration versus time. Babu, please consider concentration of reactant versus time. Concentration of reactant versus time. Okay, I am taking the graph of concentration of reactant versus time. And the concentration of reactant initially is maximum, but as during the course of reaction, the concentration decreases exponentially with respect to time. So you are getting like this. So this is the graph of concentration of reactant versus the time graph is like this. Now, just to consider two concentration slots like this at a time t1, and this is C2 at a time t2. Okay, I take it. यहाँ पे C1, यहाँ पे C2, T1, T2. तो यहाँ पे एवरेज रेट कैसे मिल जाएगा आपको? एवरेज रेट इज इक्वल टू क्या बात? C2 minus C1 by T2 minus T1. Okay. So that can be written as minus delta concentration, minus delta concentration by delta T. So this gives the average rate. Okay. Sir, negative क्यों आया सर यहाँ पे? So ये C1 is maximum, C2 तो minimum हो जाता है ना? तो the value will be negative ही आ जाएगा ना बाबू? Understand? C1 greater than C2 मतलब you are getting a negative value. And यहाँ पे it indicates the decrease in concentration. Here the negative sign indicates a decrease in concentration. You are taking with respect to reactant, so it decreases. That indicates the negative sign. So this is the average rate that is not significant in our kinetics. Okay. Next, now if you go through the second one, instantaneous rate. So, understand, rate of reaction is generally expressed in two terms. One is average rate, the other one is instantaneous rate. Instantaneous. Yes, you can understand with this long ways. Instantaneous. What does it mean? At that instant of time, at a particular time period, at a particular second, or at a particular point of time, that is called as instantaneous rate. Okay. So ये कैसे define कर सकता है? So ये the ratio of change in concentration to the change in time. The ratio of change in concentration to the change in time, which is infinitesimally very small. Okay, the ratio of change in concentration to the time which is infinitesimally very small. So very small, very finite time में जो change आएगा concentration, that's what we call the instantaneous rate. And it is significant because it covers a small time interval. Okay, So it is significant since it covers a small time interval. Since it covers a small time interval. Okay. सर ग्राफ में कैसे डिस्क्राइब कर सकता है फ्रेंड इंस्टेंटेनियस रेट कैसे ले सकता है आप याद रखिएगा इंस्टेंटेनियस रेट कैन बी रिटन लाइक दिस माइनस डी कंसंट्रेशन d change in concentration by dt. Okay, so minus d concentration by dt that gives it instantaneous rate. Okay, now if you consider the graph, Babu, first you can get a graph of average rate like this. If you go through concentration versus time period, concentration of reactant versus time graph is like this. So this plot gives the average rate. Now the tangent of the slope gives instantaneous rate. The tangent of the slope which gives instantaneous rate. The tangent of the slope gives instantaneous rate of the process. Right? The tangent of the slope gives instantaneous rate. Have understand? So this is the average rate and as well as instantaneous rate. Okay. Now let me go through in detail. See, physical chemistry is quite interesting chemistry now. If you follow a proper way and it's a purely formula based. If you have a little logic in your mind and if you are thorough with formulas, you can get a very good knowledge in physical chemistry. Understand? It's quite easier also. डरने का जरूरत नहीं है एक तरीका से एक प्रॉपर वे से आप फॉलो करने से आपको फिजिकल केमिस्ट्री बहुत आसान रहेगा ठीक ओके नाउ हाउ टू एक्सप्रेस रेट ऑफ ए रिएक्शन एक केमिकल रिएक्शन दिया गया उसका रेट कैसे आप एक्सप्रेस कर पाएंगे सो लेट मी गो थ्रू दैट पार्ट ओके नाउ एक्सप्रेशन for rate of a reaction of a chemical process. Expression for rate of reaction of a chemical process. Okay, let me assume a reaction. Just assume a reaction. A gives rise to B. A gives rise to B, where A is reactant and B is product. Okay. So what happens during the course of reaction? During the course of reaction, what happens? The concentration of reactant gradually decreases and concentration of product gradually increases. Okay. Therefore, rate with respect to A, मतलब reactant is equal to minus d concentration of A by dt, and whereas rate with respect to B is d concentration of B by dt, क्योंकि with respect to product increase हो रहा है ना इसलिए यहाँ पे नेगेटिव साइन नहीं है. So rate with respect to A minus d concentration of A by dt and rate with respect to B d concentration of B by dt. Okay, have understand? So like that we can express the instantaneous rate. Next, at any instant of time, rate with respect to A must be equal to rate with respect to B. Therefore, क्या लिखते हैं? Minus d concentration of A by dt is equal to d concentration of B by dt. But this is actually called as that what you call rate expression for rate of reaction. This is what we say expression for rate of reaction. Okay. Now, let me go through some other examples also. 。 You better to go through see the chemical equations, right? See ammonia formation. N2 plus 3H2 gas gives rise to 2 NH3 gas. This is the formation of ammonia. इसका एक्सप्रेशन कैसे लिखते हैं? माइनस डी कॉन्सेंट्रेशन ऑफ N2 by dt is equal to minus 1 by 3 minus 1 by 3. Sir, why you are writing 1 by 3, sir? यहाँ पे why don't you write 3, sir? Because they are taken in 1:3. अरे we are equating them. We are equating them with respect to rate. मतलब इसमें 1/3 कंप्लीट होने के समय में ये कितना डिकम्पोज हो सकता है, बिकॉज 1:3 रेशियो में यू आर टेकिंग. So the decrease, the disappearance of nitrogen and the disappearance of hydrogen you are equating. So the disappearance of nitrogen is equal to 1/3 of disappearance of hydrogen. Okay, so that's why that minus indicates the disappearance. D concentration of H2 by dt is equal to 1 by 2 D concentration of NH3 by dt. But this is what you call the basic expression for rate of reaction. इसको हम words में भी लिखते हैं. मतलब not only like this, you can write expanding words also. ऐसे rate of disappearance. Rate of disappearance of N2 is equal to 1 by 3 into rate of disappearance of hydrogen. Okay, if you want to compare nitrogen and ammonia, then rate of disappearance of N2 is equal to 1 by 2 into rate of appearance of ammonia. Rate of appearance of ammonia. अगर खाली rate of appearance of ammonia चाहिए तो तब क्या करेंगे? A2 इस तरफ आ जाएगा, तो 2 into rate of disappearance of nitrogen. Like that also you can understand. Okay. And one more point there. 1 by 3 into rate of disappearance. 1 by 3 into rate of disappearance of H2 is equal to 1 by 2 into rate of appearance of NH3. Okay, so like that you can understand. So expression for rate of reaction of a chemical process can be described like this. Okay, now let me go through one or two questions based on this topic. Right? Okay. I just taken a question here. A gaseous reaction A2 gas gives rise to B gas plus half C gas, B plus half molar C gas. Shows an increase in pressure from 100 mm to 120 mm in 5 minutes. Therefore, rate of disappearance of A2 in mm minute inverse is mm minute inverse. Okay. Now, how you can solve this question? Obviously, it's a gaseous phase reaction. So, change in partial pressure divided by time लेना पड़ेगा. Okay. So, with respect to what you can find change in partial pressure, you better to go for the least mole ratio वाला जो C respect से हम क्वेश्चन आसान से कर सकते हैं. See, I am trying in my style. Please check it. Okay, ये gas है gives rise to B gas plus half C gas. Okay, so initially जो भी pressure है that is okay, initially जो pressure है वो 100. Product तो नहीं रहता है. Next, after some time इसका P by 2, इसका P, इसका क्या होगा? 100 minus P. Due to conversion, some pressure तो decrease हो जाएगा ना, dissociation की वजह से. So 100 minus P by 2. So 100 minus P by 2 is equal to 120. तो 100 plus P by 2 is 120. So P is equal to कितना आएगा? 40 आएगा. P is equal to 40. Then, so now you got it. The change in partial pressure is 40. Okay. Therefore, rate of disappearance of ये पूछ रहा है, मतलब change in partial pressure by time. So 40 by 2 that equal to 8 mm. Sorry, 40 by 5 that equal to 8 mm minute inverse. Okay. See, you can solve this question in different style also. I just made like this. Okay. Understand or not? See, go through another question. In an experiment, A plus 2B gives rise to C plus 2D. The initial rate minus D concentration of A by dt is at T equal to 0 is this much. 2.6 into 10 power minus 2 molarity into second inverse. Find the rate with respect to B, मतलब minus D concentration of B by dt at T equal to 0. मतलब is asking initial rate with respect to A दिया, initial rate with respect to B पूछ रहा है. तो इसके लिए first we have to go for the expression of rate of reaction. We have to go through expression for rate of reaction. कैसे? Minus D concentration of A by dt is equal to minus 1 by 2 D concentration of B by dt. ये से इनसे हो जाएगा. Just to compare A and B, no need to write all the terms. Say D concentration of A by dt, decrease in concentration with respect to A is equal to half into decrease in concentration of B with respect to time. Okay. Now, therefore, ये समझ गया आपने? तो rate of disappearance of A is equal to half into rate of disappearance of B. Half into rate of disappearance of B. Therefore, rate of disappearance of B is equal to 2 into rate of disappearance of A. So आपका solution तो मिल गया. So 2 into rate of disappearance of A कितना दिया? 2.6 into 10 power minus 2. So that's about 5.2 into 10 power minus 2 molarity into second inverse. So that's it. So like that we can compare the rate. Okay. And initial rate you can find like this. Okay. Understand all of you? So it will be continued in next class, like factors and other points. I'll continue this whole chapter in 4 or 5 parts. So kindly like these videos, subscribe these videos and share these videos. Thank you all. Right.